Humans are obsessed with intelligence. We build particle accelerators, write symphonies, invent mathematics, and teach machines to learn. Intelligence is the trait we quietly believe makes us special. But here's the uncomfortable question: what exactly is intelligence? And are we even measuring it correctly? Because the deeper scientists look, the harder it becomes to define. At first glance, intelligence seems obvious. Solve problems, you're intelligent. Fail, you're not. Simple. Except, reality refuses to cooperate. Because intelligence is not one ability. It is a collection of skills working together. Learning, adapting, strategizing, creating, remembering. Think of it less like a single trait and more like a toolbox. And once you see it that way, something surprising happens. You begin to notice intelligence everywhere, even in places you never expected. Every intelligent system, from animals to humans, begins with three foundational tools. Tool 1, information. To survive, a living being must constantly gather data about the world: light, sound, smell, touch. But external awareness isn't enough. An organism must also monitor its internal state: hunger, fatigue, pain. Without information, you are completely at the mercy of your environment. But information alone is useless if it disappears instantly, which leads to the second tool. Tool 2, memory. Memory allows the past to influence the future. Instead of relearning everything from scratch, an organism stores experience. Locations of food, threats, safe paths. Over time, memory transforms raw experience into guidance. But the real power emerges when memory combines with repetition, because that creates the third tool. Tool 3, learning. Learning is the ability to refine behavior, to improve, to adapt, to become more efficient with each attempt. And once these three tools begin working together, even very simple organisms can display shockingly effective behavior. Which brings us to one of the strangest examples in nature. Imagine a creature with no neurons, no brain, no consciousness as we understand it, just a single enormous cell. Yet when placed inside a maze, it explores its surroundings, marks where it has been, avoids dead ends, and discovers the shortest path to food. Almost like it remembers, almost like it thinks. Whether we label this intelligence or not, one fact is undeniable: it works. But evolution rarely stops at good enough. Some animals go much further. Consider bees. Researchers once trained them to solve a completely unnatural task: moving an object to reach a reward. At first, the behavior seemed mechanical, but over time, the bees improved. They began choosing the most efficient options, adapting strategies, optimizing effort. This is no longer rigid programming. It is flexibility, and flexibility is where intelligence starts becoming powerful. But some animals push it even further. More complex brains allow something extraordinary: the ability to store vast associations, connections, mechanical tricks, problem-solving patterns. Think of this as a mental library. And few creatures use it more creatively than raccoons. Raccoons have become legendary urban survivors. Given locked containers, they rapidly figure out how to open them: bolts, latches, multiple step mechanisms. Even after long periods, they remember the solutions. Their success isn't random. It's the result of accumulated knowledge. But knowledge alone is not the peak of intelligence. The next tool might be the most powerful of all. Creativity happens when the brain stops following known paths and invents new ones. It's like connecting unrelated ideas into useful solutions. In one study, animals were taught to drop stones into water to reach food. But one individual ignored the method and simply tipped the container over. Less effort, better solution. That is creativity. Planning means acting today for a reward tomorrow. It requires evaluating possibilities and predicting outcomes. Take squirrels. They don't just bury nuts, they have a strategy. They evaluate each one and even fake burials to mislead competitors. To deceive another mind, you must first recognize that other minds exist. Intelligence is shaped by the challenges an organism faces. Not every species needs the same tools. Predators need tactics. Social animals need recognition skills. Grazers benefit more from memory than strategy. Evolution does not aim for maximum intelligence, only useful intelligence. Developing abilities that will never be used is simply too expensive biologically. But one species took a very different path: the human upgrade. Humans didn't just expand the toolbox, we multiplied it. Language, abstraction, symbolic thought. But our greatest breakthrough was something else entirely: culture. The ability to share knowledge across generations. No single human could build a spacecraft, but millions of minds, connected across time, can. Culture turned intelligence into a collective force. And with it, we reshaped the planet. Yet this power came with consequences. Because intelligence does not only create solutions, it also creates new problems. Climate change, technological risk, biological threats, which leads to a sobering realization: having intelligence is not enough. We must choose how to use it. Intelligence gave us the power to understand the universe, but it also handed us responsibility. For the first time in Earth's history, one species can influence the future of the entire planet. The tools are already in our hands. The question is no longer whether we are intelligent, but whether we are wise. Every creature alive today is solving the same fundamental problem: how to stay alive long enough to pass something forward. But humans are attempting something unprecedented, shaping the future consciously. And the decisions we make in the coming decades may echo for thousands of years. If exploring the deepest ideas about intelligence, existence, and the future of our species fascinates you, subscribe, because the next question we explore might change the way you see yourself and the world around you.